Hi everyone, today we're going to be going over problems 1 to 20 on the 2025 AMC 8. Let's start. Problem 1 reads, the 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the 4x4 grid is covered by the entire star? So it's a 4x4 grid, so we know that there's going to be 16 total squares. 16 total squares tells us that we already have 4 squares here, and these two make another square, these two make another square, these two make another square, and these two make another square, for a total of 8 squares. So 8 over 16 is 1/2, which is 50%. So problem 2 reads, the table below shows the ancient Egyptian hieroglyphs that were used to represent different numbers. For example, the number 32 is represented by the hieroglyphs as shown. What number is represented by the following combination of hieroglyphs? So we know that we have this over here, 4 of these, which is this, 2 of these, and 3 of these. So since there's 3 ones, then that's going to be 3 plus 2 times of these U-shaped pieces plus 20 plus 4 times the curly bracket ones plus 1 time the 10,000 hieroglyph, which gives us 10,000 plus 423, which is answer choice B. Problem 3 reads, Buffalo Shuffle is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and 3 of her friends play Buffalo Shuffle, each player is dealt 15 cards. Suppose 2 more friends join the next game. How many cards will be dealt to each player? So we know that when Annika and 3 of her friends play Buffalo Shuffle, there's 15 cards. There's a total of 4 people, so 4 times 15 is 60 cards total. When 2 more friends are joined, then that's going to have a total of 1 plus 3 plus 2, which is 6 people. So 60 divided by 6 is 10 cards for each person, which is C. Lucius is counting backwards by 7. His first 2 numbers are 100, 93, and 86. What is his 10th number? So his 10th number will have subtracted 7 9 times, right? So 7 9 times. So we simply need to do 100 minus 7 times 9, which is 100 minus 63, which is simply 37. B. Okay. Let's go on to the next problem. Betty drives a truck to deliver packages in a neighborhood whose street map is shown below. Betty starts at the factory labeled F and drives to location A, then B, then C, then returning to F. What is the shortest distance in blocks she can drive to complete the route? Okay, so she starts at F, then goes to A. Since she can't go diagonally, this is 3 squares. Our count is 3 so far. And from A to B, this is the closest. That's 3 plus 7, which is 10. And then we go from B to C, which is 6. And then we go from C to F, which is 5. Which gives us a total of 24. Yeah, so 24C. Seku writes the numbers 15, 16, 17, 18, and 19. After he erases one of the numbers, the sum of the remaining 4 numbers is a multiple of 4. Which number did he erase? So we can use modulos here. 15 modulo 4 is basically the remainder is 3. This is 0, this is 1, this is 2, and this is 3. Summing all of these, we have a modulo of 3 plus 2, which is 5, 5 plus 1, which is 6, 6 plus 3, which is 9. So 9. But then we subtract one of the numbers, and the remaining 4 numbers is a multiple of 4. So that means after I subtract the modulo n, it must be divisible by 4. The only way for this to happen with these numbers is to subtract 1. So we know that the number corresponding to modulo 1 is 17, so the answer is C, 17. On the most recent exam on Prof. Zoshi's class, 5 students earned a score of at least 95%, 13 students earned a score of at least 90%, 27 students earned a score of at least 85%, and 15 students earned a score of at least 80%. How many students earned a score of at least 80% and less than 90%? So basically we're trying to find the number of students that are below here but above here. So at least 80%, we know there's going to be 50 of them. But less than 90%, we know that there's 13 students who scored at least 90%. So we just need to subtract this from 13 to give us 37. D. Isaiah cuts open a cardboard cube along some of its edges to form the flat shape shown on the right, which is an area of 18 square centimeters. What is the volume of the cube in cubic centimeters? So since the area is 18 square centimeters, we can first find how many squares there are. There's 1, 2, 3, 4, 5, 6. So over 6 is 3. So the area of each of the squares is 3. Then that means that the side length of one of the squares is root 3. And simply we can just do root 3, and since this is root 3, the volume is just root 3 cubed, which is 3 root 3, which is A. Problem 9. Ningi looks at the 6 pairs of numbers directly across each other on a clock. She takes the average of each pair of numbers. What is the average of the resulting 6 numbers? Okay, let's just draw the lines real quick. This goes with this goes with this, goes with this goes with this, and this goes with this. Okay, so the average of, let's start at 1 and 7. 1 and 7 is just simply 4, 2 and 8 is 5, 3 and 9 is 6, 4 and 10 is 7, 5 and 11 is 6, and 12 and 6 is 9. This is 8, sorry. So if we sum all of these, this is going to be 9 plus 13 plus 17, which is 39. And 39 divided by 6 is simply just 13 over 2, which is 6.5 b. Okay. In the figure below, ABCD is a rectangle with sides lengths of AB equals 5 and AD equals 3 inches. Rectangle ABCD is rotated 90 degrees across the midpoint of side DC to give a second rectangle. What is the area in square inches covered by the two overlapping rectangles? Okay, so it wants us to find the area that is covered by the two overlapping rectangles, which is this. Now, one thing we need to remember in this problem is that rotations preserve distance. So that what that means is that the length of this is going to be equal to the length of this. And since that this point is exactly half of the length of the side, then this should be pretty easy to find. So we know that AB is 5, so the length of this is 5, and AD equals 3 inches. AD equals 3. So, in fact, we can just simply note that this is 5 over 2, and this is 5 over 2. So this is going to be 25 over 4, and 25 over 4 is just 6.25. So now we know that the area of ABCD is 5 times 3, which is 15. So 15 plus 15 equals 30. And 30 we need to subtract off the overlapping to get the total area. So minus 6.25, which gives us just 23.75, which is D. Okay, problem 11. A tetromino consists of 4 squares connected over the edges. There are 5 possible tetraminos, I, O, L, T, and S, shown below, which can be rotated or flipped over. 3 tetraminos are used to completely cover a 3x4 rectangle. At least one of the tiles is an S tile. What are the other 2 tiles? So this is an S tile. Let's try to put it in here. What if we put it right over here in the middle? This problem is best solved by experimentation. So if I put it here, then I have 2 L-shaped pieces left. Hey, 2 L-shaped pieces. Let's just see. Okay. The region below consists of 24 squares, each with side length 1 centimeter. What is the area in square centimeters of the largest circle that can fit inside the region, possibly touching the borders? Okay, so we know that this must be the center in order to maximize our circle. Of course, we can't just make the circle this, because this is kind of small. But instead, what if we make it bigger and bigger? This looks like it's the biggest it can be, right? And we know that this is going to be the biggest, because this length is going to be the largest. Anywhere further out, we're going to extend past this border over here, that border. So what we need to do is we just need to find this length. But this length is root 5 because we have the Pythagorean theorem, right? This is 2, 1. So it's just going to be 1 plus 4, the square root of that, which is root 5. So to find the area of the circle, we just need to do root 5 squared times pi, which is 5 pi. See. Each of the numbers 2, 4, 6, all the way to 50 is divided by 7. The remainders are recorded. Which histogram, shown here, displays the number of times each remainder occurs? So 2, 4, 6, 8, 10, and on all the way to 50. Let's see if we can find a pattern. This looks like 2, 4, 6, 8, we can take it by modulo 7, which is 1, and 10 is 3, 12 is 5, and 14 is 0. And then 16, we go to 2. 18, the modulo is 4. Hey, it seems like we're repeating, right? So after we get this, it's just repeating on and on. So this is at 1, it's 14. Okay, so what is the nearest multiple of 14 to 50? The nearest multiple of 14 is 42. 42 is the nearest multiple. So after that, we have 44, 46, 48, and 50. And 44 modulo 7 is simply 2. This is 4. This is 6. And this is 1. So that means that we have, since the closest modulo is 42, then this pattern repeats 3 times. So there's going to be 3 times of 1, 2, 3, 4, 5, 6, and 0. So there's going to be 3 times of 1, 2, 3, 4, 5, 6, and 0. But then there's going to be 3 more times of 1 more time each of 2, 4, 6, and 1. So this is going to be, there's going to be another 1, 2, 4, and 6. So we simply look for the histogram with 4 times 1, 2, 4, and 6. 1, 2, 4, and 6. Everything else is 3. So A is going to be our answer. A number n is inserted into the list 2, 6, 7, 7, and 28. The mean is now twice as great as the median. What is n? Okay, let's first sum all these numbers so it's easier to find the mean later. 2 plus 6 is 8. 8 plus 7 is 15. 15 plus 7 is 22. 22 plus 28 is 50. So 50 plus n over 6 will be 2 times the median. Let's just call that n. What we can do now is we can start plugging in numbers. Let's start from e. So this is going to be 84 over 6 is equal to 2 times m, which is the median. Okay, and 84 divided by 6 is just equal to 24. And right now the median will be, if we add 34 to the end, we have the median will be 7 and 7, which is 7, so this doesn't work. Hold on, 84 divided by 6 is actually 14. So 14 is equal to 2 times m. And in fact, m is 7, so this does work. So the answer is E24. K draws a 6x6 grid. He colors 13 of the unit squares silver and the remaining squares gold. K then folds the grid in half vertically, forming pairs of overlapping unit squares. Let m and m equal the least and greatest possible number of gold on gold pairs, respectively. What is the value of m plus m? So he folds it in half, so let's draw the line on which he folds it. Then in order to make sure that we have the least amount of silver, the least amount of gold on gold pairs, we first need to find how many squares are gold, right? So 36 minus 13 equals 23. There's going to be 23 gold squares. To find little m, we can first color all of these and all of these, so none of them overlap. That's going to be subtracting 23 minus 12 equals 11. So there's going to be 11 squares left that we can use. Then we are forced to color all of these and all of these. This gives us 5 overlapping ones over here. That's 5. That's going to be the little m. Now we need to find big M. So what's the most amount of squares that can overlap? Since we have 23 total squares, we can color this, 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 and then this. This gives us that there will be an overlap of 11 squares over here. So plus 11 equals 16, which is answer choice C. 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 24 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? Since we know that none of them can differ from 10, why don't we choose 1, 2, 3, 4, and 5? And instead of choosing 15, because then that would differ by 10, we can't also choose 14, we can't choose 13, we can't choose 12, we can't choose 11. So let's choose 16, 17, 18, 19, and 20. this satisfies the condition. So if we sum all of these, this is the sum of 1 to 5 is 15. This we can do 36 over 2 times 5, which is 90. 90 plus 15 equals 105, which is our answer, choice C. In the land of Markovia, there are 3 cities, A, B, and C. There are 100 people who live in A, 120 who live in B, and 160 who live in C. Everyone works in one of the 3 cities, and a person may work in the same city where they live. In the figure below, an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second city. For example, 1/4 of the people who live in A work in B, which is shown over here. How many people work in A? Okay, so since we know that A stated above has 100 people, we can first write that here. 120 live in B and 160 live in C. 160 live in C. So first, let's find the amount of people who work in A coming from C. That's going to be 1/8 of the population of C, which is 20. The amount of people working in A from B, on the other hand, is 120 over 3, which is just 40. And now we need to find the amount of people who live in A and work by themselves in A. So the amount of people who leave A to work is 25 from A to B, and from A to C over here, that's going to be 20. So total, there's going to be 100 minus 25 minus 20, which equals 55 people who stay to work in A. Now we add 55 plus people who go over, which is 20, and also 40 plus 40, which gives 60 plus 55, which equals 115. 115 is answer choice D. Okay, problem 18. The circle below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the 2 circles have the same area. What is the radius r in units of the circle on the right? Okay, so first let's try and find the shaded area of this. We know that a circle with radius 1 has an area of pi. And we know that the area of the square is 2. Why? Because by the Pythagorean theorem, since this is 90 degrees, 1 squared plus 1 squared is 2, and the square root of that is root 2. So root 2 times root 2 is 2. So the area of the shaded region is pi over 2. Now, if we let this be r, we can find an expression for this. Since if we connect this, this will be 90 degrees. So that would be exactly 1/4 of the area of the circle. And the area of the circle is given by r squared times pi. Now if we divide that by 4 to find this area, we know that the area of this entire sector is going to be r squared pi over 4. Now we know that the area of the triangle is r times, since this is r2, over 2. So we simply need to subtract r squared over 2. And we set this equal to pi minus 2. Now, if we solve this, then we multiply both sides by 4, which gives us r squared pi minus 2r squared equals pi minus 2. Okay, so since this is equal to pi minus 2, we can start putting in some values. R squared pi. Let's try to take the r squared out. R squared times pi minus 2 is equal to pi minus 2. So r squared equals 1. Okay, so problem 18 now. The circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the 2 circles have the same area. What is the radius r of the circle on the right? Let's first find the area of this shaded region. Okay, so we know that the area of a circle with a radius of 1 is pi. And we know that the area of this square is going to be 2, because by the Pythagorean theorem, this length is root 2. And root 2 squared is 2. And so we now have to find an expression for this area. This area is just the area of the sector minus the area of the triangle. The area of the sector is r squared pi over 4, since this is 90 degrees, right? So we need to divide by 4. Now we subtract off r squared over 2, which is the area of the triangle. And this is going to be equal to pi over 2. Now, if we multiply both sides by 4, r squared pi minus 2r squared is equal to 4 times pi minus 2. This, when taking it out, when factoring, we get this equals 4 times pi minus 2. So r squared equals 4 and r equals 2, which is answer choice B.